Welcome everybody to the first talk of this room. Next to me is Roland Weigand. He's helping out in moderation. The first speaker of today is Rimma. Sorry, I can't really pronounce your last name very well. Dzhusupova. I hope you can repeat that better than me. We work together with Rimma from McDermott already quite some time, and it's really impressive what she does. She leads an internal artificial intelligence team, and the nice thing about this is that the things they develop for the entire McDermott company are really put into practice and are really enabling their engineers to do their work way faster and better. So it's really impressive work. And we are very honored to invite to welcome Rimma to this first talk of the day.
Thanks, Wouter. And that's okay with my surname; nobody can pronounce it, so Rimma is fine. Right. All right. Now, my name is Rimma, and I work in McDermott. It's a large EPC company with more than 30,000 employees. And today I'm going to present about our real-life applications, which we developed together with VIKTOR, where we integrate AI in our engineering workflow. Let me start sharing my screen. So 1 second. Yes. I think I start sharing, right? Yes, yeah. So within the company, I'm leading artificial intelligence initiative. It's actually AI department for engineering. And our scope is basically how to improve our internal workflow. So all our product is not commercialized. It's pure for internal client. Let me give a couple of words about McDermott and what we are doing. What you see here is various installations, offshore platform, gas processing plants, and etc. So we are, as a company, we do engineering, we do the concept design, we do engineering, we procure all the materials, and we deliver the complete installation to the client. And it can be any type of facilities, starting from refineries. We also work with them. Energy companies. For example, we're building offshore stations from the wind park, gas terminals, and you name it. So installation, which usually have a investment cost more than $500 million. So the work what we are doing is, let's say we deliver as a turnkey project, and then client is further operating these installations. And our client usually it's like BP, Shell, Total, so big operators. So we don't do operation of all these facilities. And if we look on AI within the energy sector, so most of the application is focused on the operation. So next slide says a little bit more about this. So what you see here is AI integration within the energy sector. And let's say the summary out of it, it could be that most of their tools and solutions which has been developed for this business sector is focused on predictive maintenance, inspection, analyzing the data receiving from the equipment to make sure that the proper maintenance has been done, and also improving the assets, their lifetime, and the efficiency. But not so much has been done for engineering itself, and that's where our focus is. Because let's say the operation, it's a completely different sector, and we are, as an EPC company, engineering, procurement, and construction, our benefits, our profit is how good we do our engineering work, how fast we do it, and how fast we do the construction. So less we spend, let's say if we meet our schedule, then how we basically getting the profit. And therefore, when we look on the market nowadays, there are some solutions available, but because of the complexity of the work we are doing, there is no plug-and-play solution. So that's why we decided within McDermott to develop something our own, which is using our own data, our own experience, capturing our own experience, and making kind of tailor-made solution for ourselves. And the main purpose to do it is to automate repetitive job and also improve our engineering design, improve the quality. And the final goal is to reduce the actual cost which we spend for engineering and which we spend during the construction. Main driver for this is that engineering costs are getting more and more expensive, and less we spend, more we earn as a company. And also, of course, we want to be sustainable. We don't want unnecessary energy loss, material loss. So we want to reduce our wastage as well. Yeah. And let's see. What I'm planning to talk today is not particular. Going into techniques how we are doing this, but more examples of how we're applying artificial intelligence, particular within engineering and during construction, and also basically to share with you real life examples. What has been implemented, what has already returned its let's say investment cost, and the applications which we developed already save a lot of hours and a lot of money, basically, while for us while we're performing the large scale engineering projects. Yeah? So one of those examples I would like to share is let's say they're finding engineering mistakes or design mistakes on the drawings. As a company, we are producing a lot of drawings when we're developing the projects. It can be thousands and thousands, even tens of thousands, very complex drawings. And our designers, they're actually creating them. They're with the different software programs. However, there are certain typical mistakes which designers can do. Yeah, it's based on the experience and based on their just human mistakes. Yeah. Here, one of them is represented. So what you see here, it's a valve. It's called butterfly valve, which is usually let's say integrated in the pipeline, and it can control the flow. It can reduce, it can stop the flow, and so on. And most of the time, for safety reason, we put blind behind. So to make sure that if we want to do the maintenance of the valve, that the valve is isolated from the flow. And what you see here, that's the graphical representation. So this is the valve, this one, and that is the blind, which is this one. And what you see, there's a piece of pipe in between, because if you put the blind just behind the valve, it's just that the internals of the valve will crush the blind. Yeah, so it's not going to work. And this pipe, so you have to put some distance in between, yeah, which is this piece of pipe called spool. Sometimes, and to be honest, it's quite often happened that designers, when they draw the drawings, when they do the design, they just forget it, and they put the blind just behind the valve. On the complex drawings, it's impossible to catch these mistakes while reviewing, because it's as I said, we have thousands and thousands of documents produced per project. And what happened, that these mistakes go into the construction, and only when maybe just before the test, these mistakes is being revealed. And then, let's say, such a very simple, small mistake can cause a huge chain of unfortunate events. Because in this case, let's say this pipe has been already isolated, it has been already prepared for test, It might be connected to a very expensive compressor, which costs a couple of $100,000s of dollars, even several millions. And then you have to reschedule all the construction. You have to reschedule all the tests. And at the end, it might lead to the schedule delay. And schedule delay for us, it's the biggest disaster, because then we pay fine per each day of the delay. And sometimes it could reach millions of dollars. It's called liquidated damages, for example. So those mistakes, which looks very innocent, they can create huge constraints on the during the construction and for the delivery of the projects. Something similar you can see on the second picture. So the same things here. So we have here like a control valve, and on each side of the control valve there is small drain valve. They're also indicated over there. And sometimes it's also been forgotten. So what we do what we decide to do within McDermott, we decide to create, based on the deep learning, to create the model which can spot correct and incorrect representation of the patterns, basically to spot these mistakes. And for this, we create a state-of-art training database with the various patterns, with various type of mistakes which could happen. And then we train it's based on supervised learning, we trained our model to recognize those mistakes. It's very easy to say, but it's very difficult to implement. Because on here you see the representation of just let's say correct pattern, incorrect pattern. Yeah, also here, correct arrangement, incorrect arrangement. But when you work with the real-life documents, the variation of the patterns can be enormous. What you see here is just an example of variation. So this is the incorrect pattern, like similar what you see over here. But for example, there's some text appears. There's different representation of the symbols. Lines might be a little bit different. There is a dashed line alongside the solid line. Some highlights, even there's some markups. So a lot of noise, various text, a lot of additional information can appear on the drawings. And the symbology variation, yeah, so it depends each client. It depends on different clients. So Shell, BP, Saudi Aramco has different symbologies, how they different way of standards, how they represent the symbologies. And also we have different standards like European standards, American standards. So preparing even the training data set, labeling it, it's state of art and enormous amount of work. So our programmers work together with domain expert. They work together with the labels, people who is doing labeling. So that's quite a work to be done even before it goes for the training. Yeah. So that's one of the example. Another example is sometimes we have where we are receiving the tender documents. For example, if Shell decide to build a plant, they send us the let's say thousands of drawings and asking, could you estimate what will be the cost of the future plant? So what we do in this case, we're receiving the very complex drawings, which you see here, and there is no other way how to estimate the materials than just manually count each individual symbol. So you see here, you start counting each individual symbol, put it in the Excel table, and also you count, let's say you extract the text also manually, you extract some other information. So it's very difficult job. It's not difficult because it takes a lot of, let's say, intelligence, but it takes really a lot of time to do so. And most of the time, this work is delegated to junior engineers. And can you imagine, you study 5 years, 6 years to become an engineer, and afterwards you are doing this type of work. So I think after a couple of years, even less, our junior engineers just running away from this business because they don't want to do this work at least for the let's say it was not what they dream of. Yeah, let's put it that way. So and that's unavoidable because there is no other way how to estimate the quantities of the materials. So what we do, we create the algorithm which based on object recognition, symbol recognition, text recognition, which extracting all this information automatically from the drawings. So basically what we, it's work on the principle, what you see, what you get. And what we do on the top of it, we use our, let's say, historical database, where we know that for this type of plants, we spend so much of this type of material. And then with simple regression models, we can make quite a good prediction of the future spendings. So we combine here our, let's say, deep learning techniques plus simple regression, which based on the very good data management system. And then we can create easily the product which help us to estimate the materials very fast within hours instead of spending days and weeks and months of manual work. So that's also one of the biggest achievements, and now it's almost ready to be deployed. Also has certain challenges, and certain challenges are related to like the drawings are very congested. There is a lot of different type of symbology, scale down, scaled up, and so on. And as well, data collection, even for prediction part, there's quite a challenges you need to overcome with regards to data collection, the pre-processing, because sometimes data is just dumped and you need to really structurize it. So those are examples where I try to show how we apply AI within our, let's say, field. It's not always that the problem can be solved only with AI. Yes, sometimes even just a simple rule-based models can also do the work. The most important is for us is just to enable the technology to be useful, let's say, in our particular domain. And if we see that rule-based simple software cannot help, then we go and evaluate whether AI can help or not. And what we are facing right now is one of the first EPCs. I think we're not the first, but definitely one of the first EPCs who actually doing AI internally, who is developing this type of applications. The difficulties is, first of all, the lack of references. There is a lot of white papers written, a lot of potential revealed about how AI could be applied in our business. However, there is no really reference to the successful use cases. In fact, everything that we develop, it's like first of the kind. And that makes it difficult because it's difficult to estimate the budget, it's difficult to estimate how many hours it's required to develop, what kind of skills it's required. So we are discovering while developing the tools. And that also has some drawbacks because when you ask for the investment, you at least need to know some number. And that's always a challenge. Do you overrun the budget pretty quickly? Another thing is also to convey the message, because nowadays, especially after ChatGPT boomed, everyone has a feeling that AI can do magic. No, AI is a tool, but you need to have some certain prerequisites to apply it properly. For example, simple document management system. Without data, you cannot apply AI. Yeah? And that also creates a lot of, let's say, challenges in bringing up the message such that it will be understandable, and also dealing with expectations from the corporate management. And maybe last but definitely not the least is lack of resources. Because when we're talking about AI development, we need machine learning engineers, deep learning programmers, we need data science people, and our sector, like energy, oil and gas, it's not actually the first sector or business or where those type of people are looking for job. So we really need to attract them And we're doing through the academia. We engage a lot with universities. We engaged a lot with young engineers, providing internship and later hire them. So kind of bringing the message that we also do AI work, that we also do development, and we can, let's say, also bring our contribution in general sustainability to meet sustainability goals. Yeah, because the work which we are doing, it helps to reduce energy costs, it helps to reduce wastage of materials. It's also release engineers to do some more valuable work than just manually count things on the drawings. Yeah? So that's, I think, the message I try to convey. I'm not sure how I'm good with the timing, so hopefully I'm still within the time frame, but I'm open for the questions.
Rimma, thank you very much. You are perfectly on time, so that's perfect. Thanks. Very clear presentation. There were some questions coming in. The first question that came in was from Mohammed Ukaibar, and he asked, how can we recognize these mistakes? By computer vision or by labeled data?
Well, it's all related to computer vision techniques. Yeah. So what we do, we taking the drawings. I'm still sharing the screen, or not really?
No, you're not sharing screen.
Okay. Now I'm sharing. So what we do, we label indeed within the drawings, like this, the patterns, and then it's images basically. So we label like good images, bad images. Yeah. So correct, incorrect, and then we give it to the model for training. So that's yeah, it's like with any object recognition. So we kind of applying the similar techniques. The only, let's say, the challenges here was what I say, it's variations. So sometimes, for example, if you train it say on certain pattern, there's inside variations, like noise. It can be really hampered the quality of the let's say how good it recognize which is correct pattern or not correct. And those mistakes were let's say the examples of these patterns we take from domain experts. So domain experts telling us, look, this is typical mistake, or this is correct, this is incorrect. So could you train the system that it will recognize it? So that's basically that's. I'm not sure if I captured the problem, the question, but
I think we did.
Super.
So, I think we did. Rimma, if I can also ask you another question. You already mentioned it's these are quite new technologies, so I can imagine that users also might see it as a black box and are hesitant using these tools. How do you convince your day-to-day engineers in using artificial intelligence in their daily work?
Well, I think that our being concern is not to convince them to use. Our biggest concern is, let's say, they immediately think that this tool will work 100%. It will recognize 100% of mistakes. It will not miss anything, and so the expectation is just too high. So my biggest challenge is manage their high expectations. Yeah, because if you would ask me this question 2 years ago, then yes, you are right. There was a little bit like skepticism what AI can and cannot do. But this year it was a boomer. Like this year, everyone I think was convinced that AI can do everything. So
Does
so
it
now
help
I'm
that
dealing with expectations.
Well, it's the nice way around. Does it help that you have, let's say, ChatGPT kind of, let's say, common AI tools available in the market now that people are getting used to using AI?
Well, definitely ChatGPT, the launch of ChatGPT helped. So since April, there is a lot of changes happening. I mean, also in people's mindset. We do have also internal products also developed together on the VIKTOR platform, which use not ChatGPT but GPT models to work with our documents, and it also helps. Yeah, so our engineers, they are getting more familiar with AI, so it's
Yeah.
became less a black box.
Yeah.
It still sometimes actually not scare them. Some skepticism is existing, but it's much less. Yeah. So
Cool.
this type of tools definitely helping indeed. Yeah.
Thanks. Yeah, so we have 5 minutes left that I was looking at the questions. There's also another nice question that about the data. You mentioned good clean historical data is a hard requirement. Was
Yes.
most of the time spent cleaning and obtaining, structuring the data, or is it really on implementation?
Well, it depends what type of product. For example, let's say prediction. Yeah. So the model is simple. It's just simple regression model. I mean, you can build it within a days. Yeah, even less. Fine tuning is a different story, but you need to get the data to work with this model, and that's, for example, we gather the data from 200 projects which has been executed last 20 years. Yeah, so you really
Yeah.
have to fetch it from the document management system. You have to organize it such that you can give it to
Yeah.
model for training. And
Yeah.
that's as a typical data science project. Yeah, 80% data gathering, 20% for modeling and fine tuning. I think it works really well here. Yeah.
Yeah.
But when you work not only with data science project like this or prediction, which works with prediction, but also when you work with supervised, when you do supervised learning, work with the patterns, it's also let's say the preparation, the labeling is also state of the art. We've done a lot of mistakes while doing labeling. Yeah, and we have to
Yeah.
redo it again. So it's quite difficult job. I mean, modeling also difficult there, and fine tuning and feature engineering, but the preparation of the state of art training data set is also quite time consuming.
Yeah.
Yeah.
And if companies, let's say, miss out on their data, or they do projects but they didn't really archive them pretty well, which might be a typical case in engineering construction, what would you advise such a company? Is there, let's say, still a way forward?
Yeah, well, definitely to start with document management system as soon as possible, because they are actually putting themselves in the position that they soon will be out of the market, because those products, they improve our overall performance, and then it means that they will be just losing competition. And gathering data, proper document management system, it's the core. Yeah, for everything you gather tabulated data, you gather images, drawings, whatever, but it's you have a repository from where you can fetch it. So
Yeah.
without these prerequisites, I think it's very difficult to implement AI in your company. You still can do it. You can still do something with generative AI and maybe some other things, but not fully engaging your, let's say, your potential.
Yeah.
So, or potential of AI in your to be applied within your company.
Rima, there's a stream of new questions coming in, and we have only 2 minutes left. So
Okay. I try to be very, very
yeah.
sharp.
So
Sorry.
there's one of the other speakers, Marina, who will be speaking as well in this room. Have you considered other AI approaches that don't necessarily require large historical data sets in your applications? If so, which ones?
Yeah, we're now working with the generative AI a lot. So basically, also it's one of the products we developed together on your platform. We launch it from your platform. There we don't need a lot of data. So we basically working with let's say with project documentation. Yeah. So you load the documents, you query on the documents, or you fine tune LLMs specifically for your company data, for your company standards. So it doesn't require the big archive data. No,
Yeah,
it's basically tools with generative AI. That's possible.
cool. And then maybe a last one from Pedro Gonzalez Ferreira. We know how difficult it can be to implement change in organizational environment. How do you convince all organizational levels to embrace this change, including the C level?
Well, very good question. It's difficult. It's step by step. I think the biggest, the most important things, you start small and then scale up. You don't aim big project at once and then raise expectations and then don't deliver anything at the end because it's just too complex and you are not so experienced in developing it. So better to start from very small product, like even regression model using historical data and some prediction of whatever material cost or hours, and then see that it works, and then scale up for you then engage with 2 more projects, 3 more projects, and then one by one you deliver. Then the trust is increasing with the project management or with corporate management, and then you start looking for the bigger projects. And it took me 2 years to reach to be let's say at the moment where we're talking to the C-level people for the large investment nowadays. Yeah, but it's not there from the day one.
Yeah.
So it's a lot of patience also required. Yeah.
Thanks. Rimma, I think
Right.
we have to wrap up. This was a really nice kickoff of this event, a very interesting talk. Thank you very much for joining and
Thank
your
you for
time and
inviting.
preparation spent. Yeah, let's keep on talking. You can keep on talking to Rimma as well in private chats. So if you have some questions still left, you can always try to reach out to her. Thank you very much being here with us.
All right. Thank you. Thanks for inviting. It was a pleasure. Okay. Bye bye.
See you. Bye bye.